Hi, hello, welcome to the streams. Really my first one attempting to repair anything live, but we'll see how it goes. So what I've got is Nintendo Switch. Now, this one has a no power black screen issue, which is pretty common with Switches. So we'll do the usual. We'll do some diagnostics. So, what we have here is a little amp meter, and we're just going to see what this unit draws. So let's just plug it in. Okay, that's not a proper slow charge. That's 0.28 to 31 amps. Not sure how well we can see that. Yeah, it looks a bit. I think that's inverted. It doesn't look right, does it? Let's flip this real quick. Let's flip the camera. Let's see if we can improve that for you guys. So let's go to that. Right, let's see if this is properly oriented now. Yeah, there we go. So you can see that's the amperage it's drawing, which is pretty low. Typically it should draw around 0.41 amps, and then it should drop down to 0, and then it should go to somewhere north of 1 amps to show it's fast charging. This isn't doing that, so we know, there's definitely a problem. So I guess the first thing we want to do is crack this open. I'm just looking at the USB port. I don't see any obvious damage. I will have to get that under the microscope, but it's a lot easier if I've got it out of the shell to have a look. So what we'll do is we'll start off with just opening her up. So yeah, let's go for it. Let me just check I've got the right screw head on. Actually, I might have the Y head on it. I do. That would be the wrong screw adapter, so let's go with the Phillips 00, I think is what we want. Or is it? This work area is really dimly lit as well, doesn't help. Right. Let's try the 000. There we go. I'm going to pop all the screws in the same area. So yeah, that's probably the most annoying thing about repairing these systems, is actually opening them up. Not that it's hard, anything like that. Now this switch actually looks like it's in really, really nice condition. It's pretty much mint. I don't think it's been opened. The screws don't have any of those telltale signs that somebody's been inside it. Because oftentimes the screws kind of go white, they lose their colouring and so on when people have been in it. So yeah. Always fun opening these things up. So right, I've got the screws there, I've got the 2 on the bottom, I've got the 2 Joy-Con rail screws, so it's just the back screws now. So now I need the Y-wing screw adapter. Let's double check those are actually Y. Yep. Sometimes when the screws get dinged up, if people have had these open a few times, they'll replace the screw set, and you'll find that rather than be a Y-tip screw, there'll be a posi screw, because they replace the screw set. Not that there's anything wrong with that, I totally get it. Nobody wants screws that are falling apart that are hard to unscrew or screw, So yeah. Right, so there we go. We're now screwless. Let me just lift that off. Just make sure that's all in good condition, which it is. Oh, except one. That's gone. Not a problem though. 2016 unit as well, so this is definitely unpatched. I like the unpatched units. This is in really good condition. I'm genuinely surprised. Anyway, it's time to take off more screws. So we've got a whole bunch of retaining screws on this sort of back shielding plate. Kind of doubles up as a giant heatsink as well, which is nice. Helps the cooling of the switch. Because that little system-on-chip Tigra can get pretty hot when it's pushing out those pixels. Great little machines, these. It's going to be interesting to see what's wrong with this one. So, I'll just pop this SD card reader off. There we go. You know, it's not the most riveting stuff, is it? Watching somebody just disassemble a game console, but there you go. Needs must as the devil drives. I guess I could have started the stream after I'd done this, but hey, you know, whatever. So is that all the screws on that? I think it is. Yep. Well, that's factory okay. I don't think that's ever been opened. No water damage on the water damage sticker. Those haven't been torn. Yeah, that's in good condition. That's a really good condition switch, actually. Got a feeling it's never been worked on. I'm really hoping that the USB port's in good condition. I mean, it won't be a huge issue if it's not. I can replace it. But still. So let's get zoomed in a bit. There we go. Right, you can see here we've got this sort of foam stuff. And this has never been damaged, so I want to try and get it off without breaking it, which is doable. If we can just get this scalpel under it. Or maybe if I get some IPA on it. A little bit of IPA will help. And what that'll do is it will just soften up the adhesive holding this down. And that just allows us to take it off intact, because, you know, why damage something that doesn't need to be damaged, right? I mean, I guess I'm just being a perfectionist, and yeah, don't really need to be, do I? There we go, that's that one released. You can see I'm just being real gentle. I'm treating it with care. Ah, it's a little tricky. But I think we're nearly there. I'm just using the blunt end of this scalpel to release the adhesive. There we go, that should do the job. So we now raise this just a little bit because we want to release it from the thermal compound that's holding it to the top of the heat spreader on top of the system on chip. So definitely unscrewed that, haven't I? Yeah, this is held pretty firm. Wow. There we go. Now, iFixit has a guide on how to open these, and it says to lift from this end and lift up. If you do that, you'll actually bend this heat pipe. Don't do what iFixit say. Instead, sort of hold it toward this end, toward where the fan is. Just sort of maneuver it out like that, and you're far less likely to damage it this way. And it looks like even with the best of intentions, there's adhesive left behind on that fan, but that's not a big issue. Okay. The next thing we want to do is start disconnecting the cables on the board. There is this module as well that needs to be released. So I'll release that module first and detach that, and that lets us get at the other screws and gets easier access to the other cables as well. So I'll just take a spudger, slide it under connector, and it's got a little interlocking mechanism. You just use a little bit of pressure and that'll take that right off, and then you can just pop the ribbon connector right out like that. Nice and easy. And then there's one screw holding the cartridge slot board down, so you just take that out. And that's it. And then what we want to do is take the spudger, put it under where this daughter board mates to the main motherboard, and just sort of pry it up gently. Just like that. And there we go. Pop that aside. And you can see we've got access now to a screw there, and we can now access all these fan screws as well. We do want to remove the fan, actually. It makes removing the motherboard a lot easier. Again, some disassembly guides that you might read online tell you to just sort of maneuver the board out, but there's a little plastic ring around the fan here that helps hold the board in place, and you're just making yourself more work than you need if you don't take the fan out. Just undo all those screws like that. And before I undo the rest of the screws on the board, I'm going to start unplugging all the cables on the board. I'm going to do that under the microscope because it's a lot easier to see and it's a lot easier to do under the scope. Some people can do it by hand, but I'm a bit of a kludge, so I'll probably break something. So there we go, there's a microscope view. Now let me get things in focus for you guys and for myself. So there we go. Let's bring things into view and focus the camera a bit better. There we go. So you'll notice here we've got a little locking mechanism. Oh, my focus is just a bit off now. There we go, hold on. There we go. So what I want to do is just pop out this little interlocking connector thing here, pop out that, and we'll just slide this out. Just like that. There we go. Now we can pop this fan out. Again, put it somewhere safe. I'll put it just to my right hand side. And there we go. So now we've got access to other connectors. So let me just remove that one. There we go. Now this cable here that we're looking at, this is the LCD connector. And this LCD connector is extremely delicate. It's very easy to damage these. So you want to use a spudger like this, and you want to come underneath and just do that. And then when removing it, what I like to do is use 2 pairs of tweezers and come in from both sides, which I'll demonstrate now. So what I like to do is take one set of tweezers this side, one set of tweezers this side, and just sort of ease it out gently. It's extremely easy. I can't overstate how easy it is to damage the pins inside this connector. I've no idea why this connector is so weak compared to the others, but it is. What's that? Bit of muck. I'm distracted by dirt. There we go. Anyway, so then we've got the wireless connectivity cable here, or one of them, the antenna. So we'll just pop that off. Nice and easy. And then we've got some more cables down here. So we've got the other cable for the Wi-Fi. So again, just a case of get your spudger or tweezers. I'm going to use tweezers for this one. And just gently remove it. It doesn't want to come out. It doesn't want to play. Ah, my tweezers had a random solder ball stuck to them. Oh, lovely. So I tried a spudger again. So come in and, well, come on. There we go. Nice. And now we've got these connectors down here, so we want to release these as well. One is the backlight, which is this one, and this one to the left of it is the Joy-Con rail for the right hand side of the console, I believe. Is that right? Yeah, the right hand side of the console. And these ones, again, it's a bit like the larger cables. Just take some tweezers, come in and just pop them out gently like that. Go. I have to say, this switch is in fantastic condition. Now, the most annoying cables to detach are these speaker cables. Oh, that's interesting. That looks like solder mask. Huh. Very interesting. I wonder if this has been worked on before. Interesting, because that looks like UV solder mask. Anyway. Maybe it isn't, I don't know. So getting these off, as I say, it can be a little tricky. I'm going to try just pulling the cable a little bit. No, I'm always paranoid about doing that. Okay. I'm going to try and pull it out with the tweezers gently. So I'll come in like that, and then just... Yeah, that always happens. Gently wriggle these out. More difficult than you might think with these. Ugh, I've never come up with a good way of getting these out without damaging the plastic. In fact, I'm just going to grab a pair of needle nose pliers. I'll be back in just a second. Hopefully that'll do the job. I would not find my head if it wasn't firmly attached to my shoulders. There you go. So, with these, as long as I'm careful, I should just be able to pull this right out. There we go. That's that one, and then we've got 3 more cables to release down here. So we've got this Joy-Con connector, which again is much the same procedure as all of the other connectors on the board. Just take a spudger, come underneath and just sort of lift the lever up, just like that. And then we come in with the tweezers and just put push the cable out. Just like that. And we'll do the same again on the other speaker cable. This one. And now we'll disconnect the battery, which is just here. This battery is almost certainly dead as well. There we go. So now we'll release all of the motherboard screws. So we got one there. Let's see if I can actually get that under the microscope and unscrew it. No, I can't. I'm going to have to switch camera, I think. I'm going to switch back to the main camera. There we go. Get that out of the way. And you know, now it's just get these other screws off. Again, it's just a case of, you know, rejams all of them. Now I imagine, I'm almost certain this has never been opened before, so I imagine that all of the connectors are probably in quite good condition, with the possible exception of the USB port, because that will have had wear and tear. There we go, that is all of the screws removed, and now we can release the motherboard from the shell. And to do that, we just, as you can see, what I'm doing is I'm just lifting the board like this and just sort of wriggling it gently until it releases. And there we go, it's released. And that's it. So we now have the board out. So what I'm going to do is I'm going to place this part of the switch somewhere safe nearby. I'm going to keep this battery nearby as well. So what we want to do now, because I'm going to be flipping this over, I'm going to be checking around the board most likely. In fact, no, I'm not. Before I even do that, I'm going to do some quick diagnostic work. So just real quick, going to pop this memory module off, just like that. And I actually have a few memory modules like scattered around in my work area, and I don't want to confuse it with the others. So what I'm going to do is take a Sharpie and just color code this. So I'm just going to put a bit of green ink on here. Bit of green ink on here, and that's it, that's color coded. So now I can put that memory module out of the way, and now this board is actually ready to have some diagnostic work performed on it. So we're going to need the multimeter for this, and we're going to need to do a quick visual inspection on the USB port as well. So I'm going to do that under the scope. I'll show you guys that now. We can get a good look, because oftentimes it's the USB port being damaged that causes the issues. So now this port actually looks like it's in pretty good condition. It's tricky to see, but I think that this port is fine. I don't think we need to do anything with that port, which is great news. That's really fantastic news. So, yeah, let me refocus this as well. we go, we got that back in focus. Right, so this board. Oh, thanks for the comment. I wouldn't say I'm talented. It's just practice, you know, like anything, I suppose. Anywho, yeah. So what we want to do now is, if we take a look at the board just here, we can see we've got this sticker here, and this sticker indicates if there's water damage or not. It will turn pink if there's water damage, and we can see it's not pink. So there's no water damage in this area, which is good news. So what I'm going to do now is switch my multimeter into continuity mode, and the very first thing I'm going to check, although I'm pretty certain it's fine, is this fuse. And this fuse is this little black component right here, which I think is a 3 amp fuse. So if we just check that. Oh, interesting. Oh, no, there we go. My multimeter was being slow. So we've got continuity across that. So the normal area that tends to have problems is what we're looking at right here. Now this is the M92 T36 chip. This chip sometimes goes bad and you'll end up with shorted capacitors near it. So what you can do is place one of your pins of your multimeter, I'm just going to clean this one actually, on one of the metal grounding points on the board, and the other on each edge of the capacitor, and if it's shorted, both sides will buzz. So that side's not buzzing. That side is. Okay. I think this is a first revision switch. Now, I don't seem to be getting brilliant contact on these probes. It's taking a little time before it figures itself out, so I'm just taking a tiny bit of IPA, isopropyl alcohol, and just cleaning off the tips of these, because they have been gunked in flux and other stuff while I've been doing work on other machines, so yeah, there we go. Okay, no shorts there. Interesting. No shorts there either. Now that's interesting. I would have expected it to be most likely that there would be a short down there. That's not a problem. So the next area to check is this BQ chip. This BQ chip is responsible for charging the battery as far as I'm aware. So let's try that. No shorts there. No shorts there. Okay, so let's try continuity across this this inductor, this 2R2. Let's see what we get here. Okay, we have continuity across that as well. Ooh, this is an interesting switch. This could be a problem. Okay, okay. So what I'm going to do now, I'm going to switch back to the camera view super quick. I'm going to clean off the thermal paste that's on top of the this right here. And the reason I'm doing that is because I want to flip the board over and do some checks on the other side of the board, and I don't want to get thermal grease all over my work mat. Not that it would be the end of the world if I did or anything, but you know, why make the mess, right? So it's just a bit of IPA, isopropyl alcohol, and there we go. just take some tissue or similar, a cloth, whatever, and just get it off. It's good enough, it doesn't have to be lab clean. Well, this is interesting. This is really interesting. There's quite a lot of handwritten marks on this, and I think that's out of the factory as well. Let's get it under the scope. So we'll put this under the microscope. Yeah, you see we've got these ink marks all over it. How interesting. So here we have the P13 USB chip. This sometimes blows, but I would have expected the capacitor on the other side next to the M92 chip to be short if this had gone. I'm still going to check it. So nothing out of the ordinary there. Okay, let's check these smaller capacitors next to it. I don't remember if it's... no, I think it's these ones I want to check. Fine, 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 okay. So the next thing I can check are these EMI filters. Great. Great, that one's fine. Get that into shot a bit better. So that's fine. That's fine. That's fine. That's fine. That's fine. Come on. There we go, that's fine as well. And finally the one on the left. That's fine. So all the EMI filters are okay. Sometimes the fuel gauge chip can go bad, which is this chip here, and it's responsible for understanding the battery levels as far as I'm aware. So I can check the capacitors around it, see if any of those are short. That one seems fine. That seems fine. Fine. That's a resistor. That's a resistor. One of these is 10k, one of them's 100k, I think. I'm going to check those as well. $100k. $10k. Right. Go back to the continuity mode. Now this one could be interesting. We must have a shorted component somewhere. I'm almost certain of it. So yeah, we're getting continuity there. Okay. Let's check down by this Realtek chip. Let's see what we've got here then. A transducer, cap, not sure, okay. Let me just keep it on this angle. That's fine, that's fine. I think it's safe to say the Realtek chip's fine. I will check the 0 ohm resistors around it as well. You can probably see one at the bottom right there. Let's check that. We get continuity. Let's check these other 0 ohm resistors. Oh, I heard you beeping. I know you're fine. There we go. And you? Fine. That's fine. And that's fine. Okay. So there is a smaller chip down the bottom here. We'll just check around that. I'm not actually sure what this chip's for. Seems fine though. Continuity across the transducer. Okay. So now we have the max chip. This chip's responsible for power management. I have a suspicion maybe this is gone. Let's find out. Perhaps not though. None of the usual culprits. None of the usual culprits. This is an interesting switch. It genuinely doesn't look like it's ever been worked on either. So let's try testing around this chip. So all I'm doing now, I'm really going around seeing if I can identify any faulty ICs. So let's try this one. Okay. That's fine. I'll check the max chip. What else have we got? That looks like a MOSFET. Resistors. Okay. Some pretty massive caps on this board. Okay. Oh, I hope none of these are shorted. This is a system on chip. If this chip goes, it's gone. Hey. Okay, interesting. So I don't think any of the major chips are gone. M92 seems okay. P13 USB seems okay, as does the BQ chip. USB port looks fine. Looks like it's soldered in just fine as well. I guess all we can do now is check the chips on this side of the board, I suppose. So we've got whatever this Max 77621 chip is. Let's check around that. So caps are all fine around that. Oh, interesting. Okay. Let's check around this other Max 77621 chip. I'm starting to think that actually maybe the motherboard is fine. Maybe the battery is just dead. Maybe it is as simple as that. I hope it is. I'll try a known good battery in a minute. I was expecting something more severe. That filter's fine. Filter's fine. Fine. Check they aren't shorted to each other actually. Yep, all good so far. Yep. Yeah, all good there as well. Okay. So then if we go around to whatever the heck this chip is, it's unlabeled. I have no idea what it is. Let's test it. Resistor cap. Yeah. Okay. I think that's fine. Most interesting. Most interesting. Okay. Not sure if I actually checked this small filter down here. I probably should though. Okay. Yeah, that seems fine. You know what? I'm genuinely perplexed. I'm genuinely perplexed. So what I'm going to do, I'm going to pop the meter aside for a second. I mean, we've not found any obvious shorts on the thing, so I'm going to pop the memory module back in now. Done. I'm going to take a USB-C cable and plug it into my amp meter, and I'm going to give you guys a better view of this. So if I flip over to the cam view, there we go, move that aside. Right, there's our board, there's our amp meter, and as I said, I had, and I put it aside, a known good working battery. Where did I put that? I remember saying it, I remember holding it. And I go back to my point that I would lose my face if it wasn't attached to my head. Okay. There it is. It's buried. It's buried under switchboards. That's fine. Right. There we go. Right, we've got it. So I'm going to pop the battery in. We've got the eMMC module back in. There we go. let's have a look. So we'll get... It's a bit of a fiddly setup, this. Let me plug it in and let's watch the amp meter. Stuck at 0.41. That suggests that this could potentially be either stuck in recovery mode if somebody's had recovery mode on this, or there is a fault somewhere else on the board. We're actually getting the proper slow charge on this now, as we can see, 0.41. So the other battery was just too low. That's all was wrong with that other battery. But we would expect to see this start to fast charge, and it's not. So there is still a fault somewhere. I guess now that we've got that plugged in, let's check to see if we're getting anything on the voltage rails. So we'll flip back to the microscope view, like so. We'll just come up to the M92T36 chip, because I know there is a known chip pin up there that I can check for 3 volts. And I can check for 5 volts while I'm at it as well. Go to voltage mode. And just double check that focus for you guys and girls. There we go. Right, so 3.3 volts, 3.3 volts, 5-volt rail seems fine. So we're getting 3.3 and we're getting 5 volts. So the voltage rails are okay. Could be that the device is stuck in RCM mode. It might have Auto Rcm enabled and it just can't boot. That is a possibility. So bear with me a moment. My phone is able to inject payloads into vulnerable switches. This switch may have been previously hacked, so let's find out. So I pop this power lead out. If I switch back to the cam view, move that out of the way. So there we go, there's our switchboard. I'm plugging my mobile phone into it. Look at that. That is prompting me to inject a payload. It's detected that it's in RCM mode. Interesting. I don't think there's anything wrong with this switch. I think somebody may have sold this at some point, thinking it was broken because it had a black screen, and it's actually just got Auto Rcm enabled. That is my suspicion. That is my suspicion. I don't really want to hook everything back up though, not yet. I'm just trying to think if there's a way I can test this without fully reassembling it. There is. I could connect this to my computer and I could inject something like one of the key dumpers and just see if it's able to dump the BIS and prod keys from it, and if it can do that, then obviously the machine works. I don't think this is a broken switch. I don't think this is a broken switch at all. Only problem is, I'm going to need to hook this up to my computer. Why is that a problem? It isn't. Is it? No, I kind of need Windows. And I'm booted into Linux. This is a tricky one. This is a tricky one. So, okay. What we've deduced, there are no electrical faults that we can easily detect on this board. It is in recovery mode. It is recovery capable. That could indicate a hardware fault. What that could indicate, which would be a bit shit if it's the problem, but what it could indicate is that this eMMC module's gone bad, because when these are bad, your switch will just boot into recovery mode. Every time it will boot recovery mode. I could probably check the capacitors on this, see if any of the capacitors on this board are shorted, and I might well do that in a moment. The other thing, if it's not this chip, it's probably fine. What I could do is a few things. Problem is, I can't do it in this stream right now, and the reason I can't, as I say, I'm currently running Linux. I've got to reboot into Windows to actually do those kind of checks on the PC. I think I'm going to have to wrap this up for now, but I don't think that this is a broken switch. I will most certainly follow this up with another video. I haven't found any faults on it at all whatsoever. The only real problem seems to be that the previous battery is essentially dead, and that's neither here nor there. Either a really deep charge will get that somewhere where it's usable again, or I can just use another battery. I've got plenty spare, so it's not an issue. Not an issue at all. So I guess with that... Oh, that's interesting. Oh, no, it's not. Never mind. Ignore me. Ignore me. Yeah, so I guess with that I'm going to have to wrap up, because I see absolutely no real issues with this whatsoever. Okay, before I wrap up though, let's do one last sanity check. Let's just check if the one single capacitor that supplies the NAND memory is shorted or not. I don't think it will be. Because this is a version 1 switch though, if it is dead with that NAND module, will be possible to save it by rebuilding the NAND memory. So let's get this under the scope. There we go. I assume you can't see this yet. There we go. So there's the memory module. Yeah, looks like that's a standard memory module. Yeah, I guess let's check it. So I'm just going to check that one capacitor, because that's the only capacitor. I think it's the only capacitor on the board. There might be some on the underside, actually. We'll have a look there as well in a minute. But so we go into continuity mode. Let me find a grounding point. Yep, found one. That seems fine. And then we've got a couple of caps this side of the board as well. You can probably see all of them. There we go. So let's just check those as well. Make sure I've got a grounding point. Seems fine. Yep, I think I got lucky. I think we just have a switch that's stuck in RCM mode. And hello, Humi98. So, seeming though you're new to the stream, I'll explain what's happened with this switch. TLDR, it had a black screen. Wouldn't switch on, was drawing very low amperage. Opened it up, checked it all. Couldn't see any problems on the PCB anywhere, no shorts, nothing like that. One thing I didn't check is this battery. And I didn't check the voltage on the battery actually to see just how dead it is. So let's give that a go. So we'll switch back to the cam view and we'll just real quick check this battery while we're at it. So voltage mode on the meter. And I expect this to be extremely low voltage on this battery. I'm checking the wrong battery. I didn't take the battery out of this one. Actually, this is the battery I need to be testing. I'm a foolish fool, that's what I am. I'm a foolish fool, right. So, oh, is this completely dead? 2.6, oh yeah, that's very low voltage, okay. So I think the battery on this is completely dead to the world, needs a deep charge. And I think the switch itself is booting into RCM mode, recovery mode, automatically, which means the previous owner of this switch probably hacked it. The battery's gone dead. They've not been able to recharge the battery, and they've not been able to boot it for whatever reason. So if I plug a known good battery back in, such as this one, super quick, like that, and then I take my cell phone, and assuming I can find it, a USB cord, like so. You'll notice it flashes up Ricardo, which is the app I use to inject payloads. That means this unit is in recovery mode. Yeah, I think I'm going to manage to fix it. I don't think it's a major issue. I think the problem is it's just stuck in auto recovery mode. To fix it, really what I need to do is get the thing reassembled. I might need to replace the battery. I need to get it reassembled. I need to inject a payload, either with a new battery or after deep charging the original battery, and just see if it'll load Hecate. So yeah, it's well possible I can fix it. It depends why it's in recovery mode, because if it's in recovery mode because this NAND flash memory module's dead, which is what a switch will do, if it's just booting into recovery mode all the time, it's often because this memory module's dead. That memory module's dead, it's going to be a lot harder to fix. It's still possible, but it's only possible to fix memory units that have got a dead memory card on these older unpatched switches. The newer switches, because you can't hack them, means you can't rebuild the NAND memory. And if you can't rebuild the NAND memory, then you're SOL, really. So, yeah. But yeah, the short answer is, yeah, I think I can fix it. I think. Whether I can, and whether my diagnosis is correct is another question. What we can do, though, I can sort of partly reassemble this, and we can have a look. Let's do that. So what I'll do is I'll partly put this back together, and we'll see if we can boot into Hecate using another battery. Not this battery, because it's just too far gone at the minute. There's just not enough power in it. There's so little power that the screen doesn't even come on, which is a little surprising, but I suppose if it's in recovery mode, it's not that surprising. Excuse me. So I'm just trying to get this back together. It's always a little awkward getting these back together. You've got to get the cables out the way, and oh, it's all fun and games. Now, a couple of YouTubers I really like to watch that do this kind of work are Northridge Fix, he's very good, and The Coder, he's quite good as well. And most of what I've learned with these switches, I've learned from watching people like that on YouTube. So I highly recommend you check out their channels when you get a chance. Really cool stuff. Again, I'm just sort of spinning around like a record. we only need to get this together enough to test, so I need to get the backlight connected back up, which is this cable here, if I can get at it. There we go. I need to get the backlight connected. Do I need a Joy-Con connected if it's in Auto Rcm? I probably don't. I do need a digitizer connected though. Yeah, I think that's all I need. I think I need the LCD, the backlight, digitizer. So let's do that. So I'm going to switch back to the scope view. There we go. This just makes it a lot easier to reconnect cables and so on, because, you know, they're pretty small. Tweezers. Oh, nice. Working on a Sunday. Okay. So what is it you do? Assuming I can read this, I'm a bit far away from the screen. What is it you do, Emi? There we go. Tricky. And I go silent when I concentrate. Oh, fair enough. Work always. Yeah. Yeah. Come on. There we go. Right, so that's the LCD connector. We'll connect up the backlight connector, which is this one. I got that in shot. Whoop, 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 whoop. Oh, there we go. Yeah. Okay. So we'll get that in as well. Do I need to plug anything else in other than this cartridge reader? And that's only because it deals with the digitizer. I think that'll be it. Right, so we've got that plugged in, and now we just need to plug this in. There we go. Whoop. There we go. Come on. Perfect, okay. Right, we know this battery's duff, so let's go back to camera view. Camera, there we go, right. So the hope is, with this spare battery, we can get some life out of this thing. Oh, I need the SD card to start plugging in as well, don't I? I'll just grab one that's nearby. Oh, they all have the foam on, that's annoying. You come off. Off you come. Come on. Come on. These come with foam on top. Foam makes it really like annoying and difficult to actually plug these back onto the main board. So what I am going to do, because I'm being a little bit lazy, being just a smidgen lazy, you know, work, what do they say? Work smart, not hard, something like that. I'm not sure I can work smart. But hey, there we go. So I'm just putting piece captain tape down to act as insulator, just, you know, I don't think I really need it. In fact, yeah, there's nothing for it to even short on. I don't even need to do that. Being stupid. There we go. Right. Oh, I hate plugging these in. I really do. They're so fiddly. Come on. Is that in? No. That in, no. That in, no. Why? Aha! Now it's in. No, it's not. Much easier when you got the back plate on to do this, to be fair. That felt like it clipped in. No, right. Cool. So I have a working switch, my own personal one, which, given that it's unpatched, means I can borrow the SD card from it, which isn't in it because, you know, that is typical of me. There we go. So, if I pop this SD card in, there we go, so we've got an SD card in there. We do need a different battery because this one's not so great. There we go. Now we need, once again, to plug this in. Inject Hecate. And then, oh my god, it works. I'm right, it's in Auto Rcm mode. I was so right. My theory panned out. Oh, I do it for fun. I do it for fun. I'm actually a software engineer. I'm not an electrical engineer, but yeah, I do it for fun. I buy stuff off eBay, repair it, and then resell it. But wow, check it out. It works. Nice. So, can it read the console info? It can. Can it read eMMC? It can. Yeah, everything's fine. This is perfectly okay. Somebody sold a switch as broken when it's not. This is... yeah. It wouldn't switch on, but it's just the battery. Nice. Score. Absolute score. Wow. That's awesome. The best repairs are the repairs that you don't have to repair. And I'm not badass. Believe me, I've spent so many hundreds of hours, like, plowing through Reddit, YouTube videos, upsetting my fiancée with all the time I've been looking at stuff, and yeah, not badass. Dedicated maybe, but not badass. But there we go. I guess my diagnostic was absolutely correct though, and I'm super pleased with that. I am super pleased with that. That's great. That's great, and this is in really good condition. There's no scratches on the screen. The shell's really nice. It's a 2016 switch. I mean, you know, this is the back cover to it. Like, there's barely a scratch on it, right? Like, look at that. That's great. Really is in good condition. I'm really happy with that. My personal one's all scratched and dinged up. I've actually got that on my backlog to replace the shell on it, but I'm starting to think maybe I should abandon that for this one. Yeah, cool, cool. Well, I guess there's not much more to this video because it works. I might leave it on a deep charge for a while. In fact, while we're at it, let's check. Let's verify the Auto Rcm thing. We should see that on here. RCM. Come on. Look at that. Look at that. It's on. I was absolutely right. Absolutely right. Let's disable that. Right, okay. Let's restart it. Power off. I'll just gently maneuver this into shot because it's got a bunch of loose PCBs. Oh wait, I didn't plug in the power button. I'll have to pop the USB back in just to get it to switch on. Oh. Oh. Interesting. Blue screen. Yet it loads recovery mode. How? The mystery thickens. This doesn't work. I'm getting happy over nothing here. Okay. Okay. What could cause a blue screen? This isn't Windows, so it'll be something more serious. What could cause a damn blue screen? Just when you think it's going good. I'm actually surprised it loads Hakate, though. Huh. First instinct, corrupt memory. Could be. Could be. Alright. Gently turn this thing back over. Alright. If it's corrupt memory module, this makes sense. A blue screen would make sense. Alright, see you around, Humi. Have a good one. Thinking mode, thinking mode. Come on, battery, disconnect. I don't want to break the PCB. Come on, come on. That's it. Come on. There we go. I'm going to have to think on that, because as I say, I didn't see any major electrical problems anywhere on the system. A blue screen could be that the processor needs to be reballed, but I don't think so. I don't think we'd have even got into the recovery mode with Hakate booting up. Could be RAM, could be faulty memory. I doubt it though. I think it's this. I think it's the memory module. Almost certain it's the memory module. If I get this thing together again, or together enough, I can always dump that memory. Well, the mystery deepens. I'm going to end this stream here anyway, because that's the sort of thing that I'm not too sure on, and I'll need to do a bit of research on and take it away. But at least the problem's diagnosed. I didn't think it had one, but, you know, it's definitely not booting, so there is an issue there. Anyway, thanks for joining me, guys. Yeah, this has been fun. I'm going to go away and do some research now, and maybe get myself some dinner and some other bits. But yeah, that's it. Thanks for watching, and I hope you'll have a great rest of your Sunday, and yeah, have a good time. Take care, all. Bye for now.